Understanding your React UI as a tree. Introduction to UI as a tree. Hello, everyone. We're going to look into a interesting aspect of React and modern UI development, which is understanding your UI as a tree structure. So this concept you might already be familiar because it isn't just limited to React. It's a fundamental idea in computer science used to represent hierarchical relationships. So when we talk about UI, whether it's in web browsers or mobile applications, these interfaces are often structured as trees. So for example, the document object model or DOM, which browsers use to render web pages, is a tree of HTML elements. Similarly, mobile platforms use trees to manage their view hierarchies. So understanding this tree structure is really important for grasping how React organizes components and manages rendering, which in turn helps us in debugging, optimizing performance, and managing state effectively. So this example is just a simple HTML structure, which we will draw a parallel with React components. So understanding component structures in React. So React has a unique way of managing UIs. It models the interface as a composition of components, each potentially nesting other components, forming what we call a component tree. This structure is intuitive if you think of each component as a node in a tree, with parent components having child component as their branches. So this hierarchical model is powerful for understanding the relationships between components, making it easier to manage data flow and state within your application. Let's delve deeper into how this model facilitates the rendering process and aids in application development. The render tree concept. So the render tree is a concept that represents the structure of a React application at any given point in time. So it's essentially a snapshot of the component hierarchy during the rendering process. So each node in this tree represents a React component, and the connections between nodes represent parent-child relationships. And this structure is crucial for React to determine which components need re-rendering when state or props change. By visualizing your app as a render tree, you gain insight into how components interact, which is invaluable for debugging and optimizing your app's performance. So this example is a visual diagram of the app's component render tree based on the previous code. Component composition and the render tree. So React's true power lies in component composition, which is the ability to build complex UI from simpler reusable components. So when we render app, we can visualize its structure as a render tree, and you can have an app as the root node and branching out to other components such as main content or section, aside, and so on. This visualization helps us understand the nesting and composition of components and illustrating how data and callbacks flow through the app. Conditional rendering and the render tree. An interesting aspect of the render tree is how it adapts to conditional rendering. So Conditional rendering in React allows components to render different elements or components based on certain conditions. This can lead to changes in the render tree structure between renders. So, for example, main content might conditionally render a special feature component based on the value of feature enables. And this flexibility demonstrates how the render tree is dynamic, changing with each render pass to reflect the current state of the app's UI. The module dependency tree. So moving beyond components, React apps also involve a module dependency tree. So as we break our app into modules, separate files that encapsulates components, functions, or constants, we create a tree structure where each node represents a module. And the edges in this tree represents import statements showing how modules depend on each other. And this tree is crucial for understanding how your app is bundled and how to optimize load time. So for example, analyzing the module dependency tree can reveal opportunities to lazy load certain parts of your app, reducing the initial load time. We'll definitely talk more about lazy loading. Practical implications, performance and debugging. So understanding the render and module dependency trees has practical implications for your app's performance and maintainability. So by analyzing the render tree, you can identify top-level components that affect the rendering of child components, helping you pinpoint performance bottlenecks. Similarly, leaf components which have no children might be re-rendered frequently, offering opportunities for optimization using techniques like memoization. Moreover, understanding the module dependency tree helps in optimizing the app's bundle size, ensuring faster load time and a better user experience. Conclusion and further exploration. To wrap up, viewing your React UI as a tree is a powerful paradigm that can significantly enhance your understanding and management of complex UIs. So this definitely helps in debugging, optimizing performance, and structuring your code more efficiently. As you develop with React, I encourage you all to explore further into React rendering process, conditional rendering techniques, and efficient bundling practices. These concepts will not only improve the performance of your application, but also make the application more maintainable and scalable. Thank you for joining the lecture.